go back to our main program. The thing we have to do now is associate our schematic parts, components with footprints, and that's done in the second stage, CV-PCB. Again, it gives us the warning, no problem, it's just the first time we're using it. Here's a list of all the footprints that are available in the program. This is a list of our parts, and here it wants us to specify the footprints we want to use. Now, how do you know what's what? Well, the easiest thing to do is to open the part viewer. I'm going to do some resizing here. Here's our part viewer, and basically you browse until you find the footprint you want. In the case of our LM741, I happen to know that we want a DIP 8 300 ELL. So once I find it, I just double click, and there it is. For my resistor, I happen to know there are several different resistor packages. So there's an R4 large pads, R4, and so on. I happen to know we want an R3. That's the name of this guy. Double there. Double click. Double click. Our power input, I happen to know, it's an SIL3, just a 3-pin connector. And my input and output are 2-pin connectors. So I've associated my parts with their footprints. We're done. Save. This is going to save it back into the net list. There it is. Next phase. Finally, PC board. Our warning, nothing to worry about. First thing to do, set up some design rules and your layers. Design rules, well, these are good enough for me. Right now, actually, no, I'll make those bigger. I'm going to use, as my default, 12 mils and 10 mils. For my track or trace width and the clearance between them. Next thing to set up are the layers that my design is going to require. These are the different kinds of Gerber files, or they correspond to the different Gerber files the program can output. We don't need adhesive. We don't need solder paste. We do want silk screen on the front. We do want solder mask on the front. We want a two-sided board, so we want front and back. We want solder mask on the back. However, we don't need silk screen on the back, solder paste, or adhesive. We want this layer for indicating our PC board edges, and we may as well keep these as well. So when I click that, here you'll see these are the actual layers that make up my board. Next thing, we have to read our net list, or read the selection, the listing of parts, the connections, and their packages or footprints into the program. So I selected the net list, and I read the current net list. And it looks like nothing has changed. But in fact, if you look up here, there are all your parts. And they're rather unfortunately piled on top of each other. So there's a mode that we can enter, manual or automatic, place, like that. Right click, and we can move all modules, and that will actually spread out the modules so that you can actually start to move them around. I'll just select these and move them down. Okay, there they are. Now I can just use the same move and rotate stuff. I'm going to move this guy here rotate them. I'm going to move this guy. There's our power connection. Actually, probably want something like that. Here's our input. Move them. Is that our input or output? We'll find out soon enough. That over here. So see the white lines? See those white lines? Those are what we call rat's nests. Those indicate the connections that you will eventually have to make. And those rat nests can actually help you put things in the best location. So we can see here that, all right, that's related to that. So I'll do something like this. Actually, that's going to be better. And maybe I'll stick that right there. So there's my parts laid out. Now that I've laid out my parts, I want to indicate the edges of the PC board. What size do I want to make this? What's the sizing? So I select the PCB edges layer, and then I can just draw my edges. So this is how big my board is going to be. A couple other things I'd like to show you, but we're running really low on time. If you give me 5 minutes, I think I can finish most of this up, at least the most important bits. Now what I have to do is actually make these interconnections. I have to make these interconnections. I have to place the tracks. So when I start placing the connections, I will do them either on the top layer, which is called front, or I'll place the connections on the bottom layer, or a combination. So I'll start on the front, and what I usually do is I go for the easy stuff first. I do the easy stuff first. So to lay a track, you use this guy. Add tracks and vias. Just select the tool, click, click, escape, click, double click, you're done. Click. Now notice this is going to do some intelligent sort of stuff for me. That's good. Click, double click, that's done. Click, 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 double click, that's done. Double click, select that. It's going to go there. What else needs to happen? Looks like these need to get connected. That's a ground. If you try to make a mistake, it won't let you. It will reject your attempted connection. So what else do we have left? Looks like that has to go there. That has to go there. This should go here. Again. Looks like this needs to connect here. And it looks like that's going to be a little tricky. I could go around this way, but I'm going to use this as an opportunity to show you how vias work. So what I'm going to do here, I'm going to start on the top. And I'm going to bring it down here. And then what I'm going to do is I'm going to change layers. I'm going to change layers by adding a via. Place via. When I place my via, I've changed layers. So now I'm on the bottom, and I can connect. So what we've done is that we've gone from our top through a via to the bottom. What's left? What's left? We've got this guy. I'll do that on the top. And, oh, looks like another opportunity to use a via. So I'll come out here. Maybe right here. Place a via. Come up here. We're done. That's routed. Do a design check. No problems. You want to check the unconnected tab to make sure that everything's connected. Everything's connected. That board is done. This board is done. To produce files for manufacturing, simply go to File, Plot. And here, you first specify the layers you want to print. You may as well print all of them. You select the output directory, and I usually create a new directory to store my Gerbers. And we plot. Our files are created. I also want to generate a drill file. In the same place. And there are our Gerber files. It's always a good idea to check your Gerber files to make sure that everything came out the way you expected. That's what this tool does, Gerber View. When you open Gerber View, you can load Gerber files. Here I'm in my K4 directory. These are all my Gerber files. Open them, and there are my Gerber files by layer. Oops. I wanted to grab this guy. And you can turn layers on and off over here. So there's our silk screen layer. There is a solder mask layer. There is a pad layer. No, that's probably a paste layer. There's our top layer, I'm guessing. And our bottom layer. And there's our outline. And that's about it. Obviously, there's a lot more detail we could go into. But I could send this file out now, these set of Gerbers, out to Alamex, Batch PCB, or a number of other places, along with about €50. And they'll send me back PC boards that I can use, solder onto, and build my prototypes with. That's it.
How long does it take to work?
If you need to rush, you can, for a surcharge, they can rush things, and I believe do things in like 1 or 2 days. I think their normal processing time is about a week. So post to get there, you email them the Gerbers. They'll take a week to schedule and do your stuff, and then post to get back. So, about 10 days.
How do we change the kind of vias?
This program, I believe, well, let's find a good question, actually. That's something I haven't looked into. I'm not sure. Nope, that's the Gerber viewer. We want to be here. I don't know if you can actually specify whether vias are tinted and so on. Yeah, no, that's a very good question. I'm not sure. The answer is I'm not sure. That issue's never come up. I use, I think by default, KiCad will produce tinted vias that have the solder mask on them. And The only time you really want untented vias is when you want to do something like a test point, a point where you actually want to make a connection to test something. And if you want to do a test point, you probably want to indicate that test point in your schematic as a one-pin part, and then that'll show up as a pin rather than a via. Because you'll want your test points documented in the schematic.
And how do we change the drill size? You know, there's a problem
The
with
drill
the
size,
potentiometers.
the size of holes, that is specified in the actual footprint.
Okay.
So the footprint, this is the module editor. Load a module. Let's just grab one from a board. Okay, this is a typical footprint. These are the pads. When you specify a pad, you will specify the drill size. So you'll specify the shape, and somewhere there is an opportunity here for specifying, there, the drill. That's the size of the drill. So that information is encapsulated in the footprint, typically. Anything else? I've got time. If you've got time, I'm happy to spend some more time here. If you've got more questions, if you want to leave, we're done. Any other questions before I let you go for real? Questions? No?
If you have no questions, we'd like to thank you.
Thank you. It's been fun. Thank you.